I, Abhishek Misal, welcome you to on the comprehensive lecture on register and shift register. In this lecture, we will study the another application of flip-flop. Here, the flip-flop uses as a memory device which store the data as well as transfer or shift the data as per requirement of our engineers. The detailed description of shift register and register will be studied here. The first topic is register. Register is a collection of flip-flop used to store binary data. Register transfer. In the era of digital system, the foundation lies in the register and the components responsible for data processing. At the core of digital operation is the concept of register transfer, a fundamental operation where binary information moves from one set of register to another set. This transfer can be direct from one register to another or may involve passing through data processing circuit to undergo specific operation. Visualizing this process, consider the figure 1, where binary information orienting from a keyboard undergoes a serial of transfer. In this setup, an input unit includes a keyboard, a control circuit and an input register. Each keystroke prompts the control circuit to input an 8-bit alphanumeric character code into the input register. Assuming the use of ASCII code with an odd parity bit, the information from the input register is then shifted into the 8 last significant cell of a processor register. After this transfer, the input register is cleared, ready to accept a new 8-bit code with next keystroke. Successive 8-bit characteristics are moved into the process register, with each new causing the previous one of shift leftward. Upon the completion of transferring 4 characteristics, the process register is filled its content representing characters like J, O, H and N. In the given example, are them transferred into a memory register, making the accumulation of the process. In digital system, effective processing of binary information relies on register, which serve a data holder, and digital logic circuit, which manipulate individual bit of information. For instance, consider the scenario illustrated in figure number 2, where two 10-bit binary number undergoes addition while the memory unit, usually composed of millions of registers, is shown with only 3 of its registers. The processor unit comprises registers R1, R2 and R3 alongside digital logic circuit. In this setup, R1 and R2 contain the operand and digital logic circuit process their bits, ultimately producing their arithmetic sum in binary form, which is then stored in R3. Importantly, memory registers are repositories of information and lack of ability to process operand. However, information from memory can be transferred into processor register for processing. Likewise, result obtained in the processor register can be moved into memory register for storage, creating a seamless information flow within the digital system. In this example, the role of register as fundamental element for storing and managing binary information is evident. The interplay between digital logic circuit and register forms the backbone of digital system, enabling intricate operation and paving the way of design and functionality of complex digital system. A subject developed into a subsequent paragraph. First, the working of register. Register composition. Registers are constructed by grouping multiple D flip-flop under a shared clock signal. Each flip-flop stores one bit, allowing a register with multiple flip-flop to store a corresponding number of bits. The second operation is load, signal and clock operation. A load signal control the loading of new data into the register. When load is equal to 0, the register maintains its current value unaffected by the clock signal. When load is equal to 1, during the falling edge of clock signal, data from D input is loaded into the flip flop. For example, if Q outputs are 0, 0, 0, 0 and D inputs are 1, 1, 0, 1. After the clock falling edge, Q change from 0, 0, 0, 0 to 1, 1, 0, 1, denoted as 0 to 1 at the flip flop output. Asynchronous clear functionality. Flip flop in the register have asynchronous clear input, that is represented by CLR_N, where clear N is typically high and logic 0 momentarily apply to it clear all flip flop, setting their output to 0. Clock enable feature. Using flip flop with clock enable, that is represented by CE, input register can be designed for more precise control. When load is equal to 0, the clock is disabled, preserving the register's data. When load is equal to 1, enabling the clock allow data from D input to be loaded during the falling edge of clock. Bus notation. Register use bus notation to represent multiple data input and output. A bus signifies a group of wires performing a common function, despite as heavy line with the number of bits indicated beside a slash. The next operation is transferring data between registers. Data transfer between registers is a common operation in digital system, which is explained here. The first try set buffer enable data. If enable En is equal to 1 and load is equal to 1, the output of register A is enabled onto the try state bus. The data is stored in Q after the rising edge of clock. Conversely, if enable En is 0 and load is equal to 1, the output register B is enabled into the try state bus and data is stored in Q after the rising edge of clock. These principles are foundational in digital system design, ensuring accurate storage and controlled data transfer within the components. Understanding this concept is vital for creating reliable and efficient digital system. Several D flip flop may be grouped together with a common clock to form a register shown in figure because each flip-flop can store one bit of information. These register can store 4 bit of information. This register has a load signal that is ANDed with clock. When load is equal to 0, the register is not clock and it hold its present value. When it is time to load into the register, load is set to 1 for 1 clock period. When load is equal to 1, the clock signal is transmitted to the flip-flop clock input and the data applied to the D input will be loaded into the flip-flop. On the falling edge of clock, for example, if the Q output are 0, 0, 0, 0, where Q3 is 0, Q2 is 0, Q1 is 0 and Q0 is 0 and the data input are 1, 1, 0, 1. It means that the data bit D3 is 1, D2 is 1, D1 is 0 and D0 is 1. After the falling edge of clock, Q will be changed from 0, 0, 0 to 1, 1, 0, 1, 1. As indicate the notation 0 to 1 at the flip-flop output indicates a change from 0 to 1. The flip-flop in the register have asynchronous clear input that are connected to a common clear signal that is represented by CLR N. The bubble at the clear input indicate that a logic 0 is required to clear the flip-flop. Clear N is normally 1 and if it is changed momentarily to 0, the Q output of all 4 flip-flop will become 0. As discussed, getting the clock with another signal can cause timing problem. If the flip-flop with clock enable are available, the register can be designed as shown in the figure. The load signal is connected to all 4 CE inputs. When load is equal to 0, the clock is disabled and the register hold its data. When load is 1, the clock is enabled and the data applied to the D input will be loaded into the flip-flop following the falling edge of the clock. Figure shows that a symbol for the 4-bit register using bus notation for D inputs and Q outputs, a group of wire that perform a common function is often referred to as a bus. A heavy line is used to represent a bus with a slash with a number beside it indicates the number of bits in bus. Transferring data between register is common operation in digital system. Figure show how the data can be transferred from the output of one 2 register into a third register using tri-state buffer. If En is equal to 1, load is equal to 1, the output of register A is enabled onto the tri-state bus and the data in register A will be stored in Q. After the rising edge of clock, if En is equal to 0, load 1, the output of register B will be enabled onto tri-state bus and stored in Q after rising edge of the clock. Now, let us discuss the shift register. Shift register are versatile digital circuit commonly used in various applications such as data storage, data transfer and arithmetic operation. They allow data to be shifted in or out serially, and they can perform both left and right shift, making them essential component in digital system. Here we will explore their application in great detail and discuss the significance in modern electronics. First, serial to parallel and parallel to serial conversion. Shift register are crucial in serial to parallel and parallel to serial data conversion. In serial to parallel conversion, serial data is loaded into the shift register and then read out in parallel form. Conversely, in parallel to serial conversion, parallel data is loaded into the shift registers stage and they shifted out serially. This availability to convert data format is vital in communication interface like SPI stand for serial peripheral interface and 12C inter I2C inter integrated circuit. The second application is data delay and synchronization. Shift register are often used for delay data signal in digital circuit. By controlling the shift register, a clock data can be delayed for a specific number of clock cycle. This delay is useful for synchronizing data in system where different parts operates at varying clock speed or in application where precise timing is critical. The next application is frequency division and generation. Shift register are integral component in frequency division circuit. By feeding back specific stage of a shift register into its input, a frequency division effect is achieved. This principle is employed in frequency divider and counters, where the output frequency is a fraction of input frequency, making them useful in clock generation for microcontroller and microprocessor. The next is data encryption and security. Shift register play a role in data encryption algorithm. In application where data security is paramount, shift register are used to perform bitwise operation such as XOR on data stream. These operations combined with proper encryption key can enhance the security of transmitted data, making them vital in secure communication protocol. LED display and visual effect. Shift register are commonly used in controlling LED display by using shift register. It is possible to control a large number of LED with fewer pins of a microcontroller. This technique is applied in application ranging from 7 segment display to large scale LED matrix display. Additionally, in entertainment and decorative lighting, shift register are used to create mesmerizing visual effect by controlling RGB LED display. Serial data transmission. In serial communication protocol like UART, that is called universal asynchronous transmitter, receiver. Shift register are employed for serial data transmission between device. UART communication allow device to communicate serially without the need for shared clock signal, making it widely used in embedded system, IoT devices and computer peripheral. The next is industrial automation and control system. In industrial automation, shift register are used for various purposes such as data storage, control signal generation and sensor interfacing. They are employed in PLC, that is called programmable logic controller, and other control system to manage input from sensor and generate appropriate control signal for actuators and machinery, facilitating automation in manufacturing process. The next is error detection and correction. Shift register are utilized in error detection and correction mechanism like CRC, cyclic redundancy check, by performing specific shift and XOR operation on data string. CRC codes are generated and verify if error occur during data transmission. These codes help detect and sometimes correct the error, ensuring data integrity in communication system. In this chapter, we will discuss the working of both serial in to parallel and parallel in to serial register by universal shift register. The universal shift register present in section is a bidirectional shift register with a parallel load. The 4 clock operation that are performed with the register are specified in table. The register also can be cleared asynchronously. Our chosen name for a behavior description of 4-bit universal shift register shown in figure. The name shift register 4-bit signifying the behavior model of internal detail of the top level block diagram symbol and distinguish that model for structural 1. The 4-bit universal shift register has 2 section input. The first is S1 and S0. The 2 serial input shift left, shift right. For controlling the shift register, 2 serial data path input MSB in and LSB in, a 4-bit parallel input I parallel and a 4-bit parallel output, that is A parallel. The always block describe the 5 operation that can be performed with the register. The clear input clear the register asynchronously with an active low signal. Clear must be high for the register to respond to the positive edge of clock. The 4 clock operation of register are determined from the value of 2 select inputs in case statement. S1 and S0 are contacted into a 2-bit factor and are used as the expression argument of case statement. The shifting operation is specified by the concatenation of serial input and 3-bit of register. For example, the statement A parallel is less than equal to MSB in, comma A parallel Third, 3 out of 1. Specify a concatenation of the serial data input for right shift operation MSB in which bits are A parallel of the output data bus. A reference to a contiguous range of bits within a vector is referred to as a part select. The 4-bit result of the concatenation is referred to register A parallel 0 bit. When the clock pulse triggered the operation, this transfer produces a shift operation and updates the register with new information. The shift operation overrides the content of A parallel with the content of A parallel 1. A structural model of universal shift register can be described by referring the logic diagram of figure. The diagram shows that the register has 4 multiplexer and 4 D flip flop. A mux and flip flop together are modeled as a stage of shift register. The stage is a structural model to with an instantiation and interconnection of a module for mux and another for a D flip flop. For simplicity, the lowest level modules of the structure are behavior model of the multiplexer and flip flop. The structural description of register is shown below. The top level module declares the input and output and then 4 copy of a stage of the register. The 4 specify the interconnection between the 4 stage and provide the detailed construction of register as specified in the logic diagram. The behavior description of flip flop uses a single age sensitive cyclic behavior. A behavior model of synchronous counter with parallel load from figure shown in count, load, clock and clear B are inputs that determine the operation of counter according to the function specified in table. The counter has 4 data input, 4 data output and carry output. The internet data lines I3, I2, I1, I0 are bundled as data in. In the behavior model, likewise the register that hold the bit of the count A3, A2, A1 and A0 is A count. The carry output C out is generated by a combination circuit and is specified with an assign statement. C out is equal to 1 when the C count reach 50 and the counter is the count state. Thus, C out is equal to 1 if the count is 1, load is 0 and A is 1, 1, 1 and 1. Otherwise, C out is 0. The block diagram specify the operation to be performed in register depending on the value of clear B, load and count. A0 at clear B reset A to 0. Otherwise, if clear B is equal to 1, 1 out of 3 operation is triggered by positive edge of the clock. In conclusion, shift register are indispensable component in modern electronics. Finding application in diverse fields such as communication, computation, entertainment and automation. Their ability to manipulate data serially and in parallel along with their role in various digital operations makes them essential for functionality and efficiency of digital system across industry. As technology continues to advance, the significance of shift register in digital circuit is only accepted to grow, further solidifying their position as fundamental building blocks in the world of electronics. Thank you for watching the video.